Our next talk is by Kelsey Young. Kelsey, are you online?
Yes, I am. Thanks, Claire.
Great, go ahead, all yours.
Okay, great, thanks. So we've heard a lot today about sampling during Apollo, the science rationale for sampling, what kind of samples we're going to want from future Artemis EVAs, and about the tools being developed by the EVA tools team to support lunar surface sampling for science. I'm going to spend the next 5 minutes talking about how the procedures for how we're going to sample to set the stage for future talks today and for the sampling breakout session later today. This should be familiar to all those who have conducted fieldwork. It's based on years of fieldwork experience and through high fidelity mission human spaceflight analog projects like Desert Rats and the NEMO projects. I'll talk through the sampling procedures that Trevor Graff and I are integrating into exploration EVA planning with the JSC EVA community. But I'll say right here at the beginning that this is an evolving process. We'll continue to refine this process and these procedures with the help of the science community, especially as the more refined science objectives for Artemis lunar surface science are developed. So this is a chart that was presented back in May, and it's the Artemis surface science objectives right there across the top with the benefits of the Artemis program and answering those questions at the bottom. I don't need to tell this community that samples are a critical resource for the science community and they're critical to addressing these science objectives. First and foremost, we've heard a lot today that the best resource is a well-trained crew member who uses their brain as well as their observations and documentation skills to provide the critical science data. If the mission architecture supports it, we might also have in situ instruments, but I'll talk about that in a second. So these are the broad procedures that we're developing and integrating into exploration EVA planning. Step 1 is deciding where to sample. We call this process pre-sampling. It could be varying levels of formality, but it's the process of surveying a station to select where you want to sample. Depending on the mission architecture, you could have in situ instruments, but not nearly as important as actually making the visual observations. Step 2 is documenting and collecting your sample. You heard from Adam Nades, the Deputy Project Manager for the EVA tools team earlier. They're hard at work creating tools that are valuable for us in the science community. I won't dwell on step 3 because you heard about it from Julie earlier, but the curation community is really hard at work at refining parameters for step 3, which is the sample transport and stowage and return to Earth of the samples collected on the lunar surface. Step 1, as I said, is pre-sampling. It's the process of reconning a site to select the highest priority sampling sites. Again, it relies primarily on a well-trained crew member that makes visual observations in conjunction with the science objectives at that station, combined with documentation. And again, if the mission architecture supports it, possible instrument deployment. It can also incorporate real-time comms with MCC. We'll have really well-trained crew members, but MCC can also help assist with sample decision-making if there's real-time communications and the ability to send back imagery to that MCC team real-time. Sampling is done with the technique determined by the type of sample chosen during pre-sampling. You heard from Adam earlier about all the tools that the EVA tools team is developing. This could be a rock chip sample taken from a boulder, a regolith sample, a core sample, etc. The crew will select the precise sampling location based on their training and based on the specific science question at each site and for each sample at that site. Sample collection includes the description of the sample and documentation of that sample, which is just as critical as the sample itself in allowing the science community to understand exactly why and where that sample was taken, and of course, proper curation. The sample size will depend on the science objective. We heard a lot about that earlier today, and I'm really excited for the breakout sessions to pull on the thread a little bit more about where and of what type we want each sample taken for each objective. Now, post-collection analysis will depend entirely on the mission architecture. Especially in phase 2, when the crews will be there for longer periods of time, they could have time to analyze samples post-collection and prior to return to Earth in between each EVA. We want to maximize the utility of having a crew member during the EVA, but if there's longer duration stays, it could now allow for in situ analysis in between each EVA. This has to be worked in tight collaboration with the science and the curation teams. What we don't want is to open up samples that have been curated for return to Earth, but if there are longer duration missions, that could especially enable this analysis. What you see here is pictures from the Desert Rats test, which was simulating a longer duration surface stay, just like we expect for phase 2 of Artemis. And you can see the GeoLab pictured inside of this habitat lab, which allows for in between each EVA, the crews to analyze samples that will not be curated for return to Earth, but that allow them to understand a little bit more about the geologic context of an area where they're exploring. If the mission architecture allows it, crews could also deploy these in situ instruments real time on EVA, as you'll hear about from the next speaker. But again, the most high priority data site is just that well-trained crew member collecting observations and collecting the samples. The instruments are here to help, not to hinder. And so I'll conclude by saying sampling is, of course, a top priority. Everyone on the line agrees with that. And again, it takes place via visual observations and documentation before and during samples, as well as, if the architecture supports it, the use of in situ instruments. And Trevor and I are more than happy to take questions about this in the discussion period or via our emails here. Thanks.